Welcome to the video series, The Slit Lamp Exam. This video explains the use of retroillumination in the slit lamp exam. It covers the following topics: Illumination Principle, Usage, Specific Advantages, Slit Lamp Setup, How to apply the technique, and Common Errors. Illumination Principle. Retroillumination is a technique which illuminates the observed object with light reflected from the structures behind it. This illumination technique can be divided into direct and indirect retroillumination. With direct retroillumination, the observed area is directly illuminated from behind. With indirect retroillumination, the observed area lies adjacent to the area that is directly illuminated from behind. Usage. Retroillumination allows to detect and differentiate corneal irregularities. It is highly effective for visualizing the extent of limbal vessels and neovascularization. It is the method of choice for detecting transillumination of the iris. And it is useful in assessing irregularities and opacities in the lens. In contact lens fitting, it is used for assessing deposits and for identifying marks or defects. Specific advantages. Retroillumination uses the optical phenomena of refraction and absorption. These phenomena provide additional information which is not available when using direct illumination alone. In this example, the absorption phenomena shows which vessels are perfused. The refraction phenomena even allows to detect empty vessels. The information with direct illumination would be much more limited. In this cornea, direct illumination shows the difference between the anterior and posterior cornea, but it does not illuminate the irregularities associated with the corneal dystrophy. However, when utilizing indirect illumination reflected from the lens, you can observe the refractive changes it has caused in the cornea. When using the retina as the source of reflected light, the irregular refraction in the cornea provides an overview of how the central cornea is affected. When assessing a non-transparent foreign body embedded within the transparent corneal tissue, the foreign body will appear dark, as it absorbs the light rather than transmitting it. A transparent foreign body, however, may also refract, but not fully absorb the reflected light. Finally, the absorption-transmission phenomena allows you to detect transillumination phenomena of the iris using the red reflex from the retina. In direct illumination, this iris appears to be normal. However, when the light is directed through the pupil and reflected from the retina to illuminate the iris from behind, it reveals pigmentary loss. Slit lamp setup. To set up the slit lamp for the examination with retroillumination from the iris or crystalline lens, choose a medium to high light intensity and a slit width between 1.5 and 2 mm. Set the illumination angle between 30 degrees and 50 degrees. Choose a magnification of 16 times to 40 times. Initially start at low magnification and then augment as needed. When the retina is used for retroillumination, choose a low to moderate light intensity and a slit width of about 2 mm. Set the illumination angle between 0 and 10 degrees. Choose a magnification of 10 times and zoom in if required. How to apply the technique. To use retroillumination, focus on the area of interest and illuminate the structure behind it. With direct retroillumination, you observe directly in front of the illuminated background. With indirect retroillumination, you look just adjacent to the reflecting area. Depending on the properties of the irregularity, visibility may be enhanced by either using direct or indirect retroillumination. Due to the common pivot of illumination and microscope, the directly illuminated tissue will be in the center of your field of view. In contrast to this, the retroilluminated area is offset. In lower magnifications, this is not a problem, as the field of view is sufficiently large. But in higher magnification, demonstrated in the smaller optic, the retroilluminated area might be too far offset to observe. By decoupling the illumination from the microscope, you change the focus point of the illumination. and thus bring the retroilluminated area back into your field of view. This can be done by loosening the decoupling knob and rotating the illumination tower. For observing with decoupled illumination, we recommend the following approach. Start by focusing on the area of interest. Once you are in focus, decouple the slit illumination beam and gradually change the direction until it illuminates the structure behind your area of interest. To use the red reflex for the examination of the lens, cornea, or iris, focus on the structure you want to examine. Then bring the illumination in an almost coaxial position with the microscope. Shorten the beam to avoid disturbing reflections from the iris. You can move the reflections out of the field of interest again by decentering the light beam. Common errors. When examining the cornea, make sure that you create sufficient distance between the direct slit beam and the area that is illuminated from behind by choosing a wide angle of illumination to microscope. Otherwise, when scanning the cornea, the direct illumination may obscure or wash out the views from the indirect retroillumination. When examining the cornea of a patient with light iris, the illumination should be reduced to maintain the contrast of the corneal detail. Here an example where the indirectly illuminated field shows no detail. Here the same view with reduced light intensity. Now the epithelial microcysts are easily visible in indirect retroillumination. When examining the lens or the iris, you may not be able to find the red reflex from the retina. This may be due to insufficient light intensity, an illumination angle that is too large, or a pupil that is too small. Thank you for watching. The Haagstreit team wishes you a lot of success in exploring these optical phenomena during slit lamp examination. This episode was made possible with the following contributions.